Hello, this is Mr. Bissonette with another episode of Math in the Classroom. Today we're going to be working on using the quadratic formula to solve for solutions, or to solve for y-intercepts, the zeros, the roots, many different names for finding the same thing. So today I can use the quadratic formula to solve for the solutions. Okay, so one of the things I like to do as a teacher is I talk about what's the narrow view, what's the expanded view, looking at it as far as what we can do with it, and then what are we solving for. Big picture, small picture. So a couple things that we're going to think about before we get started. What is the quadratic formula? Okay, we'll just go ahead and get that started right now. That's going to be opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now that's different than the quadratic equation, or the starting form of a quadratic equation. Okay, so quadratic equation, or the standard form, of a quadratic equation, that's going to look like this part where we have f of x equals ax squared plus bx plus c. That being said, it is important to know the parts of this, because this a, this b, this c is exactly what we're using for our a, b, and c over here. Okay, so big picture, small picture. What are we doing? When we use the quadratic formula, we're solving for what we call the solutions. Now again, I tell my students this all the time. I will tell you the things that I like about math. I'll tell you the things that I don't like about it. This is one of the things that I don't like about it. There's about 4 different names for the same thing. That all being said, we'll explain it, we'll show you, we'll use them interchangeably, so hopefully you get used to knowing what's going on. Okay, so we have solutions. We could also call this our x-intercepts. We can also call it zeros. And we can also call it roots. Okay, so what is happening? Well, when we have a quadratic equation, it's going to be a parabola. So we're going to end up crossing this x-axis potentially twice, once, or none at all. We'll explain all of those examples as well. So when we're finding the solutions, what we're doing is we're finding out the points where this crosses the x-intercept, or x-intercepts, or crossing the x-axis. Hence the reason why we have x-intercepts. Now, the reason why we call it zeros, well, if we have an equation like f of x equals x squared plus 8x plus 15, okay, to be able to solve for where those are at where our y value is 0, or in this case where our f of x equals 0. So we're essentially setting that equation equal to 0, and we have potentially 1 or 2 or none where it crosses. Roots, well, the reason why we call it roots is because we take the square root of it to be able to get that. So that's kind of where all those different ways of explaining the same thing come from. All right, as I mentioned, there's kind of 3 different answers that we can get. Possibly 2 solutions. Okay, and this is going to happen when we have a discriminant, or inside the square root sign, that's going to be a positive number. We can have the case where We cross one time where the vertex hits the x-axis, and that's where our discriminant is going to be 0. And here we're going to have one solution. And then the third option is if our parabola doesn't cross the x-axis at all, we have no solutions. And this is the case where we have the discriminant is a negative number. Okay, so we'll let you take those notes. That's, again, big picture, small picture. We're finding out where it's crossing the x-axis. We call them solutions, zeros, roots, x-intercepts, all those different names. We have three main options of what's going to happen. It can cross twice, it can cross once, or it doesn't cross at all. All right, feel free to pause that if you need to get those notes before we move on to the next step of it. Okay, so the next thing that I do with my students is remembering these formulas are tricky, difficult, and I pre-apologize for my drawing, but we'll kind of explain it, and understanding what the picture is will help us go from there. So if we turn this formula into a picture, our brain will better remember visuals than boring numbers and symbols. So here we go. The picture for this formula goes like this: negative b. So we're going to have a b, and since it's a negative one, it's going to have a negative frowny face. It's a b, so it has a stinger. Okay, and then our plus and minus, that's going to be the antennas. So we have a plus and a minus. Square root. So we're going to make a square root, and that's going to go off to a tree. Okay. B squared. We're going to have a b now that's square. And it's going to be another negative b for our minus. 4ac. Well, what ac? Let's go with AC units. There's the cold air. So we're going to have 4 AC units. Okay, all over 2 apples. Okay, so there it is. Negative b, frowny b, plus or minus, square root, there's the square root, b squared, minus negative b, minus 4 AC units, all over 2a. So simple little picture to kind of help remember that better if you're struggling to remember the formula. Okay, back to the problem. Here we go. So we'll use this problem, our x squared plus 8x plus 15, to show you how to work through it. So like I said, our a is the number in front of our x squared. So in this case, we're going to have an invisible 1. Why does that work? Because 1 times x squared is x squared, so it doesn't change that value. Our b is going to be 8, and our c is going to be 15. Before I even get started, what I like to do is I like to label them over here. A equals 1, B equals 8, and C equals 15. All right, now let's get started. Negative B, or opposite of B. So we're going to have negative 8 plus or minus the square root of B squared. So 8 squared minus 4 times A, which is 1, and C, which is 15. That's all going to be over 2a, and a is going to be 1 in this case. Now again, as a teacher, one of my jobs is to show you where the invisible parentheses are, and right here is where our invisible parentheses are. Once we know that, the rest of the problem is simply following PEMDAS. Okay, so here, parentheses, inside here we have that set of parentheses, so that's what we're going to work with. And next it says exponents, so we're going to do -8 plus or minus the square root 8 squared, there's our exponent, 64 minus 4 times 1 times 15, all over 2 times 1. Now that we have our exponent, we're going to look at multiplying and dividing. So we're going to multiply all of this. So we're going to have -8 plus or minus the square root of 64 minus 4 times 1 is 4. 4 times 15 is going to be 60. Think of it double, 15 and 15 is 30, and then double 30 to get 60. All over 2a. Now we're going to do our adding and subtracting, 64 minus 60. So we're going to get -8 plus or minus the square root of 4, all over 2 times 1. Square root of 4 is going to be 2. Okay, so we're going to have -8 plus or minus 2 over 2 times 1. Now we can multiply our 2 times 1. And so we're going to get -8 plus or minus 2 over 2. Once we're here, you're going to want to break it up into the two separate problems. So one of the solutions is going to be -8 plus 2 divided by 2. And the other solution is going to be -8 minus 2 over 2. -8 plus 2 is going to be -6. -6 divided by 2 is going to be -3. -8 minus 2 is going to be -10. -10 divided by 2 is going to be -5. When we were in class, I asked the students, it sounds like a really simple question, but it's pretty tough if you actually think about it. Is it going to be -3 and -5, or is it going to be -3 or -5? And I let students think about it for a little bit, and they kind of argued this, that, and whichever it is. Again, big picture, small picture. What are we looking at? This parabola is going to cross here at -3 and -5. How many times does it cross? It crosses twice. Is it -5 or it crosses through? No, it crosses through both of them. So we're going to say and. Okay, what are these? These are our x-intercepts. These are our zeros. These are our roots because we have to take the square root to solve for it. A bunch of different names, all solving for the same thing. Now, something to keep in mind, you could get the same answer by factoring this. So we have x plus 5 and x plus 3. And then essentially you would set the factors each equal to 0 using the zero product property to get -5 and -3. Factoring doesn't always work. The quadratic formula always works. It's a little bit more work, but it always works. This, I would say, is a little bit easier, but it doesn't necessarily always work. So there's a little bit of a trade-off there. Also, when we're getting exact solutions, this works a little bit better for getting exact solutions. This can be a little bit trickier to get exact solutions out of that. So there's a little bit of the pros and cons of using the quadratic formula versus factoring. So I can use the quadratic formula to solve for solutions, and there it is. So again, thank you for watching. Hope you enjoy this. If you do, like, subscribe. If you have any questions, feel free to comment those. If there's some different aspect of it that you'd like us to look at, we'll work on getting that squared away as well. So again, thank you and hope you have a great day.